Welcome to your Accelerated Math 108, Module 9.5. In this lecture video, we're going to talk about applications of algebra word problems, where we're going to be dealing with number problems and something called the consecutive integers. So, in this particular video, I want to use linear equation to solve number problems. So here are the list of the most popular algebra translation words that I will need you to begin to remember. All right, words that will translate into addition. Normally, the word add is very basic. We don't see as much right now in this particular module. The word sum is very popular. I'm going to put a blue star beside the word sum because the word sum means addition. The word sum also means the answer that I get after I add. All right. The word more than, very popular. We use it quite often. All right. Increase by, the word plus also translate into addition. So I'm basically highlighting the one or write down the one that's more popular than other ones. For subtraction, words translate into subtraction. The word subtract, of course. The word difference also means subtraction sign, and it can also mean the answer that we get after we subtract. The word less than is very popular. I'm going to put a red star beside it. The word less than will require us to translate backwards. Okay. So what that means is, real quick, if I say 7 subtract 2, we normally translate it as 7 subtract 2. I write 2. So 7 subtract 2 is exactly what you think it is. 7 minus 2, 7 subtract 2. But when we use the word less than, 7 less than 2. All right, when you see 7, you write 7. But when you see the word less than, you got to remember you need to translate backwards. What that means is normally we put the subtraction sign behind what we just wrote. So translating backwards means now we will put the subtraction sign in front of what we just wrote. 7 is less than, 7 is short from somebody that's up front, which is 2. So 7 less than 2 is actually translated to be 2 minus 7. Okay, that's what I mean by translating it backwards. All right, same thing with subtracted from. We don't see it very often in algebra classes, but it translates the same way as the word less than. Words that translate into multiplication signs. All right, just like the word sum and difference, the word product means multiplication. The word product also means the answer that I get after I multiply. We use the word times a lot. When you see the word twice or the word double, those will be translated for 2 times something. Okay, put a 2 in the front, 2 times something. The word of sometimes means multiplication, sometimes it means of. So the word of means multiplication when we are dealing with percent type of problems or when we're using fraction wording like a third of, half of. Then the word of means multiplication. All right, equal signs. Phrases or words translate for equal signs such as is equal to, is the same as. So the equal sign is basically by context of the word problems. Okay, so but you can still be looking for these phrases, which I will point out in the example here. So if you read this problem, if 11 is added to a number, the result is 45 less than twice the number. Find the number. So if you read it like that, you're not really trying to think about what it says. Okay, these problems are designed for you to translate what it says and find and solve for x. So try not to think about what it says. Instead, translate. Okay, word by word. Translate them word by word. So if you see 11, you write 11. Added means plus. How do you know I got to translate that word? Because it's on the list that you need to translate. Added to a number that I don't know, so let's call it x. See the phrase is, the result is, so that establish the equal sign. All right, the next thing I translate is 45. I write 45. But the next word is less than. So when I see the word less than, that means I got to translate backwards. So normally we put the subtraction sign behind what I just wrote. In this case, with the word less than, I got to write the subtraction sign in front of what I just wrote. All right, the next word I translate twice. Okay, because up here, you got to know these words. Twice means 2 times. Where do I put it? I put it in front of my subtraction sign I just wrote. So I'm going backwards. I'm going back to the left. Twice means 2 times. Okay, 2 times who? Twice means 2 times. 2 times who? The number x. So this problem is basically translated into 11 plus x is equal to 2 times x minus 45. Okay. So let's solve for x. None of the 4 term has parentheses. So let's see. No like term to combine. So I see I got variable term on the left, variable term on the right. My 2x is bigger than my 1x, so I will move my x to the right. So that means at the same time, this negative 5 need to go over back to the left side. So with the equal sign in the middle, 2x is still 2x. When positive x come over, it become negative. On the left side, 11 still 11. Negative 45 come over, become positive 45. All right, step number 5, combine like terms on each side. So 2x minus x, x equals 11 plus 45 on your calculator should be 56. So the answer is 56. Okay, so translate what it says rather than think about what it says. Okay, that's what these problems are designed to do. All right, so let's translate. For the first number I see is 87, so I write 87. Then I see less than, so I write subtraction sign. Where? In front of what I just wrote. Got to go backwards, so we're going back to the left side. The next word I see is 4, so I write 4. Whereas in front of the subtraction sign I just wrote. 4 times a number, I write x, is equal to, so that established the equal sign, equal to who? The number, which I already called it the x. So this problem or this phrase or sentence is translated into 4x minus 87 equal to x. So instead of saying it like that, the way how the language is worded in algebra would be 87 less than 4 times the number is the equal to the number. Okay, that's the way how we actually say it. All right, so let's solve for x real quick. I only got 3 terms here. This variable term x is way less than 4x, so I'm going to move my x to the left. That means at the same time, I need to move my negative 87 over. So x come over, become negative. 4x minus x is 3x. Negative 87 come to the right, become positive. So when I divide both sides by 3, 87 divided by 3, my answer, x equals 29. All right, that's all it is to it. Okay, let's try a couple more. Translate, okay, translate. Don't think too much into it. The more you think about what it says, the less it makes sense. Because nothing here really makes any sense. Everything is kind of backwards a little bit. So let's translate. 19, 19. The next word, more than. Remember the word more than? It means what? Addition. So when I see the word more than, I write plus sign. When I see 3, I write 3. When I see times, I write times. When I see a number, I write x is equal to, see that established the equal sign. The next word I translate is actually the word difference. Here we go. So when I see the word difference, I supposed to write a subtraction sign down. But when I write a subtraction sign down, there got to be somebody go in front of it and somebody go behind it. Kind of makes sense because subtraction sign outside the parentheses separate between two terms. So it's a subtraction between who? Tells me right away. It's a subtraction between negative 31 and twice the number. So who go first? Who go in front of the subtraction sign? Got to be the first thing they name. It's a subtraction between negative 31 and the other one goes right here behind it. When I see twice, I write 2 times the number, which is x. The difference or the subtraction between negative 31 and twice the number. So this whole equation is translated to be 19 plus 3x equal to negative 31 minus 2x. Be careful, I have a lot of students are so convinced variable got to always be in the front. Not necessarily, okay? It's however, whatever the problem tell me to go first. In this case, negative 31, and 2x go in the back, okay? So just however it's worded, I translate accordingly. Except the word less than. Less than, we got to do it backwards. All right, I got 4 terms here. None of them has parentheses, so no distribution. I see there's no like term to combine on each side. So let's move our terms back and forth. So on the left side, I got positive 3x. On the right, I got negative 2x. So since 3x is bigger than negative 2x, I'm going to move all my x's to the left side. So that means my positive 19 need to go to the right. So on the left side, I already had a 3x. When negative 2x come over, it become positive. So if you're quick with this, you can go ahead and say that move over become 5x. And that would be fine. Negative 31 is already on the right. Positive 19 come over, become negative. So when I combine like terms on each side, I should have negative 5x, positive 5x equal to negative 31 minus 19, which is negative 50. So when I divide both sides by 5, my answer, negative 10, okay? Now, this example here, just separating my whole entire translation into multi-steps. So here is the sentence I need to translate. Use a variable x to set up an equation to solve the given problem. Set up the equation, but do not take the step to solve it. So step 1 out of 2 just want me to set up the equation. So that means I'm just going to translate what it says. The first word I translate, 18. I write 18. More than, I write plus. 3, I write 3. Times, I write times. A number, I write x. Because it tells me to use x. Is equal to, establish my equal sign. Again, the word difference means I write a subtraction sign down. Oh, hold on a minute. Isn't these 2 problems exactly the same? Sure is. I apologize. So this problem is just like the previous one. So, it don't hurt. Almost like it. It don't hurt. Let's translate. Subtract. Difference means subtraction sign. When I write a subtraction sign first, there got to be somebody go in front of it, somebody go behind it. It's a subtraction between who? Negative 31. They told me that go first because it listed first. And 4. Subtraction between negative 31 and who else? 4 times the number, which is x. So that means this whole equation is translated into 18 plus 3x equal to negative 31 minus 4x. Okay. So now let's solve it. So that's the answer for step 1 out of 2. So let's see. So now I'm just going to paste it right here for step 2 out of 2. So I can I can solve it here. So no parentheses, none of the four terms has parentheses. No like term to combine on each side, so let's move them. So as you can see, positive 3x is bigger than negative 4x, so I will move negative 4x to the left side. So I should get 3x is still 3x, negative 4x come over, become positive. On the right side, negative 31 still there. Since all the x is going to be on the left side, that means the 18 got to be moved over to the right. That become negative 18. So if I combine like term again, the 7x equal to negative 49. Divide both sides by the coefficient. My answer x equals negative 7. All right. So this particular video, I just show you how to, I'm trying to introduce all these translation words because these will be the words that we will begin to see quite frequently when we are dealing with algebra word problems. All right. So the next video, I will show y'all something called a consecutive integer type of problem. All right. That will conclude this lecture video. Thank you for watching.